Okay, so hello, welcome back. Now we get to chapter 8 of class 1. Now these chapters are not, it doesn't take much time to cover all of the 5 classes, and then as I mentioned before, in the first 5 classes you have, kind of something like what you could call essentially loose mathematics, meaning that you have all of these models, but they are usually in the form of stories and children and that sort of thing. And once you're done with these 5 essentially 5 classes, each would be, for example, 13, 14, 15 chapters. Then we get to class 6, and then essentially from class 6 basically you will have a different flavor of mathematics, of course in the NCERT system that we are following here. From class 6 essentially the mathematics that we study becomes a little bit more formal, right? And then once you get to class 9 or so, class 8-ish, 9 or so, then it becomes a little bit more formal, and then it essentially goes from there. Okay, so now in this video we will talk about essentially some models with essentially 4 numbers, and starting from, for example, 21 and 22 and so on and so forth. So the question here is, Simran was putting oranges in boxes. Each box can hold 10 oranges. How many boxes would she need? So she has essentially these boxes over here, and each box can take essentially not more than 10 oranges, or essentially exactly 10 oranges. So then how many boxes are we going to need? Is that essentially this is 3, 6, 9 and 10. This is another 10, and that's a 3. So then you need 1 box essentially for these 10 oranges, another box for the next 10 oranges, and then we have 3 loose oranges that we can essentially put here like this. So that becomes essentially the number 10, 20 and 23, for example. Now these boxes we can represent them as these basically grids, and each grid basically contains 10 subgrids. So you have essentially one grid over here, another grid over here, so each of them represents a 10. So that's a 10, a 20, and basically in this grid only there is one shaded subgrid, which means that then you have essentially 21, then a 22, then for example a 23, then a 24, then a 25, then a 26 and 27 and 28, 29, and then 30 would be 3 complete boxes, or 3 complete grids basically. So that's basically that. Now of course you know that basically in this way, the way that we represented these numbers, we use basically first we used these boxes, and then instead of boxes we made our model a little bit more formal, and we used these grids over here. But instead of essentially a grid or a box, you can essentially use anything any unit, or essentially any whole that contains basically 10 units, meaning that over here we have 2, 4, 6, 8 and 10. So you have 10 flowers over here in a string, and then you have another 10 flowers here, or essentially 10 beads over here, or 10 beads over here, or 10 sticks over here, all tied together. So you can use essentially anything that is a unit of 10 basically. So then for example a 31 would be 3 of these flower strings plus 1 flower. 32 would be 3 plus 2, 3 tenths plus 2 ones. A 33 would be 3 tenths plus 3 ones. A 34, a 35, a 36, a 37, 38, 39 and 40. Now instead of flowers, of course, you can use these sticks. So 41 would be 4 basically groups of 10 and a 1, 4 groups of 10 and a 2, 42. 43 would be 4 groups of a 10 and a 3. 44 would be that, and then 45, and then 46, 47, 48, 49, and 50 would be essentially 5 complete groups of 10. And that's basically that. Now, based on the models that we just studied, you can now essentially write these numbers. And basically the good thing about grouping things together is that then counting becomes very easy, meaning that, for example, we have 1, 2, 3, 4. 4 times 10 is equal to 40, and then 1, 2, 3, 4, and 5. So that's essentially 45. Now, if I keep these flowers basically as loose flowers without any grouping, then it's going to be very essentially time consuming to count each and every one of them. But then this way, what you can do is that you can just simply take this as a 10, or take this as a 10, or take this as a 10, or meaning that you don't have to count these. The only thing that you need to count is the loose ones, meaning 1, 2, 3, 4, and 5. So that's a 45, right? Or essentially, again, we have grouped these sticks together. So then I have 4 groups, that's a 40, and then that's a 7, so that's a 47. Or this is another group of, this is 4, and this is, so this is another group of 10, another group of 10, another group of 10. So that's a 32. So grouping things together is going to eliminate the need to count things. Okay, so the rest of the numbers is going to be the same story, meaning that, for example, a 51 would be 5 groups of 10 and a 1. A 52 would be 5 groups of 10 and a 2. 5 groups of 10 and a 3 would be 53, and in the same way 54, 55, 56, 7, 8, 9, and 60 would be 6 groups of 10 basically. Again, a 61 all the way up to 70 is going to be essentially the same, all the way up to 80. This is 70 and this is 80. So a 70 would be, for example, 7 groups of 10, and 80 would be 8 groups of 10. And then you can just simply keep going in the same direction, meaning that essentially a 90 would be basically a 9 groups of 10, and 100 would be basically 10 groups of 10. And of course, when it comes to grouping, now that we get essentially to 10 groups of 10, we can essentially put these, we can essentially put all of these together, 10 groups of 10, and make 1,000, a group of 1,000. And then again we can basically we can keep going in that direction, meaning that we can again keep going to make essentially 10 groups of 1,000, and make a group of 10,000, and then make a group of 100,000, and then make a group of 1,000,000, and so on and so forth. We can keep going in that direction. Actually, the number system has been made in this, the decimal number system has been made in this exact same way. Now, this is essentially some model that you might find interesting. You see over here, for example, this is a number. You can easily write the number. So that's essentially a group of 10, and essentially 4 groups of 10 plus 7 loose ones, which would be essentially 47. Or here, basically, the same groups of 10 have been represented using these blocks. So you have 1, 2, 3, 4, 5, 6, 7, 8 groups of 10, and 3 loose ones. That would be, for example, an 83. And over here, basically, the loose ones have been represented in the form of these little cubes. And then essentially, when you put 10 cubes together, you get a bar. You get essentially a 10 bar. And then, so this group of 10 and this group of 10, for example, would be the exact same thing, would be the same thing as this group of 10. So then here we have 1, 2, 3, 4, 5, 6 groups of 10 plus 6 loose ones, so that's a 66, for example. So that's essentially all about different ways of representing these numbers.